So I'm, as Ralph said, I'm Professor Jane Cleland Huang, and I'm a professor at the University of Notre Dame. So if any of you are from the US, you probably know Notre Dame because of our football team. And I have taught courses at the university where people have learned how to program drones, how to fly drones. We also have a spin-off company called Drone Response, that we're building this a company where we can deploy drones to support all sorts of emergency response missions. So to fight wildfires, to do kind of surveillance for things, to deliver defibrillators to people during rescues and things like that. And then the other question was, how long have I been working with drones? Well, I think about 7 or 8 years now. Drones were kind of pretty new around that time. And I was teaching some students programming classes, and we decided to start bringing drones in and to start programming them. And that's basically how my interest in drones started.
Do you mind if I just hop right into some student questions that have already been emailed to me?
Absolutely, yeah.
Okay, so one of these was emailed to me by a kid in France, and they wanted to know what inspired you to initially get involved with drones?
Yeah, so that's a really good question. I think, sometimes, what inspired me to do it, I think, was two things. One, I'm a professor and I'm trying to teach my students how to write programs that are for all sorts of different systems. And I want them to learn that when they're programming something that we call a cyber physical system. So a cyber physical system is something like a machine, a drone, a robot, anything that has both kind of physical, mechanical components and software programs that you write for it. All of those kinds of machines, if you program them wrong, they can actually hurt people. So you can imagine in a factory, you've got a robot, then that robot's got this huge, great big arm that is moving around and making parts and things. If you program it wrong, that arm swings really in the wrong direction. It could hit someone and hurt them. And we have been working in this area of how do you write programs for these cyber physical systems in ways that you can be sure that they are going to be safe and not actually hurt people. And so we wanted to actually have a cyber physical system ourselves. So we thought, why don't we start programming drones? And this was at the very beginning of the whole kind of drone movement, where it was very, very new to have these little drones that you could just buy and program. And drones, you can imagine, we have our system where our drones are what we call autonomous. And autonomy means that the drones are able to think for themselves, figure out their mission for themselves, do their own things. But imagine that you deploy some drones to support firefighters, for example, or coast guards in rescuing somebody that has got washed out to in the lake or something like that. The last thing you want is for that drone to have an accident and fall on top of that person and make the accident even worse. So we call this a safety critical system. And that's kind of what motivated me to get into drones. I was interested in, building a system, having a system that we could test out and think about how to write better software. And that's why we started with our drone project. at the very beginning. And it's been a great project because, you know, when you write code, you write a program and it runs on your computer. If something goes wrong, you just see a little error message and your program stops, and that's it. And what my students have told me is when they write code for drones and they see that their code makes that drone take off and fly somewhere, everything becomes really real. And if there's a bug, that drone may fall out of the sky, or it may collide, may fly away, or it may collide into a building. So bugs become more important. So it's a great area for trying out coding and thinking about all these things.
That's exciting stuff. And can you talk to the little kids? Because we got a couple of questions that were emailed to me, and they wanted to know what is one of the more exciting or memorable, would you call them missions or rescue efforts, or where your drones aided and assisted in an emergency kind of scenario?
Yeah, so we're not quite at that point yet. Our spin-off. So when you start a spin-off in this area, you have to kind of build all of the software first. And we're at the point that we have our system, and we're kind of working with potential customers. So we're kind of at the verge of deploying it into the real world. What we have done is several demonstrations with different firefighting companies. So in South Bend, which is where we are, we did a big demo downtown, and they put a firefighter into the river, and our drones had to go and find the firefighter. And then the idea is once we found the victim in the river, then they put their boats in and they were able to quickly go there. So I wish we were a little bit further and I could say that we've actually saved lives, but we haven't done that yet. And I think that's one of the challenges of a spin-off. So I have two spin-offs. That means two companies that we've developed. And the other one is software only. And it's much easier to get that kind of company started. Whereas a drone company, there's so much you have to do to get every piece of it right. Just let me just kind of say a little bit about that rescue that I told you about. In order for this to work, you have to be able to put drones on the riverbank and just tell them, here's an area, figure out between you how you're going to search that area. So that makes the drones pretty smart, and it means that they have to be able to collaborate or work together just like people on a soccer or football team. And then they have to have onboard computer vision. So they have to not only have cameras on board, but they have to interpret what they see in the camera so that they recognize when they found a person. And then they have to change their behavior. Instead of searching, they have to stop, they have to survey, and they have to maybe call another drone to come and deliver a flotation device or something like that. So it's very challenging, and we're at the kind of cusp of kind of getting our first customers right now.
And what kind of drones, one of the kids, they wanted to know, what kind of drones do you guys primarily use for that?
Yeah, so actually I got two old drones in my background. We're not using these ones. If you look behind me on my shelf there, that little blue one we can't use. It's a very little one, it's a dumb one, but we used it for lots of testing at the very beginning when we started flying drones. And then that's called an Iris. And then this other one is like just a regular hexcopter. Our actual drones, I don't have one of them here behind me. The difference is that these basically are not smart drones. So we have to send them messages from the ground, and the message goes straight to the flight controller, which is like the little mini brain of the computer, and then it flies where we tell it. Now, our drones, we have drones that we had a company build for us, and they have a computer on board. So instead of the computer on your desk, we have these small computers called Jetsons, and we put them on the computer, and then they control the drone. So we just send messages from the ground to these little computers, and then the little computers are very powerful, and they run all of the computer vision and all of the autonomy. And the autonomy is to make the drones be able to make their own decisions. Like when they see something, or they perceive something through their camera, and they say, is that a person or not? They got to figure that out. And then they make a decision. Yep, it is a person. So now we found the victim, and now we have to start the rescue. So that's the kind of drone we use. They're called hexcopters because they have 6 arms and 6 propellers. You can see this iris at the background. It's a quadcopter. It just has 4 arms and 4 propellers. This American hexcopter is a hexcopter because it has 6 of them, and they're called folding arms. So I think I'm going to go back there and show you. Let's see. So I'll bring it here. I wasn't planning on doing this, but why not? I don't have batteries here, so I can't make it beep, but you can see these arms come out like this. And at the end, they have these little propellers. So that's, you can see it's quite big. And our other drones that we fly are about the same size. They're just a lot smarter than that one.
That is so neat. We have a question from Jose, and Jose, or this one comes from Joan. Joan is in Spain. Joan, you should be able to unmute. You had a good question. Go ahead.
Hello. So I heard big drones require professionals to fly them because they are more difficult. So does the size of the drone make a difference in difficulty when you are programming?
Okay, yeah, Jose, thank you for that question. So I think it depends on how big. You can see this drone, I don't know, would you call this a big drone or a small drone? Technically, it's a small drone, and it doesn't make any difference for flying or programming, whether you're flying a drone this size or the very, very little one in the background. So quite a bit of our funding for our drone projects comes from NASA. And NASA they differentiate between what they call small drones like this, and then drones that can actually carry people. And I think when you go up to a drone that carries people, then obviously it becomes even more safety critical. If I'm flying my drone, if it falls to the ground, the chances are no one's going to get hurt. Of course, we want to be careful because there might be people underneath. But if you have people actually being carried in the drones, then it becomes way more critical. And I think the other thing that's interesting is, your question about, is it more difficult to fly them? And I think the answer to that is, nowadays, the most common way for people to fly drones still, like firefighters, is they're going to take their radio controller and they're going to use the operations. They're going to send commands directly from their radio controller to the drone. So they're basically flying it manually. But as we move forward, and what our systems do is you don't really have a human operator at all. The human just does things on the computer and tells all of the drones, let's say 5, 6 of them, to go and fly their mission. So then it's all about the software and it's less about the human operator. So in answer to your question, I think it only really gets more difficult if the drones get really much bigger and actually have people on board. And then I think the other thing that makes flying drones, whether it's from computer, which can only happen from computer, is if you go beyond visual line of sight. So if you want your drone to fly to places that you can't even see the drone, that's a whole different level of difficulty. That you need a whole different kind of training and a whole different way of developing the drone and keeping track of it than you do if you're just flying a drone that you can see.
There's a lot of training, I'm guessing. We have a couple more student questions and we'll let you go. This is Jose. Jose is also in Europe. Jose, go ahead and ask your question. All right.
My question was, what kind of materials did you use to make the drones?
Yeah, that's a good question. You can make them out of I'm not really the hardware person here, but you can make them out of all sorts of different materials. You can buy frames if you want to. This particular one is kind of made of some kind of fiber, and the propellers, of course, can be made from all sorts of different kind of materials, all the way from plastic to kind of very, very hard materials. I'm not an expert in that because we are the software kind of people. But I think the main difference in the way you make drones is, do you start off with a frame that you can buy ready-made, and then you just kind of put all the pieces together, or do you manufacture the drone from scratch? So the drones that we're actually flying for our drone response company are made by an avionics company for us. And I'm not completely sure about all the materials that they put into it. I have to be really honest about that.
You're absolutely fine. So one of the final student questions, so they want to know, what regulations and safety measures do you follow when you fly a drone? Can you just go out there, anybody, and just go and fly a drone whenever you want, however big or however small?
Yeah, that's a really good question. If you have a very, very little drone, you can fly it because it's too small for any of the regulations, even in the US. But every country has their own regulations. So depending what country you're in, you have to go and check your regulations for your own country. But in the US, we fly under something called Part 107. So these are regulations that come from the Federal Aviation Authority, and we have to comply with them. So these tell us things like what kind of time of the day we're allowed to fly. So we can only fly in daylight. If we fly at dusk, we have to put special lights on the drone. They tell us things that only one person can only fly one drone. If you want to do something different in the US, you have to get a waiver. So for example, because we have built a software system, drone response, that flies multiple drones, I had to submit a safety case to the FAA and ask for permission to fly multiple drones. And we were actually one of the very first groups in the whole US that got permission to fly multiple drones, which is really nice. So there's all sorts of rules like that. The problem is that, these are rules, but when you're flying drones, especially autonomous drones, sometimes things go wrong. And we have a rule in the US under 107 that you can only fly up to 400 feet above the ground level. And we were flying our drones, and something went wrong, and our drone hit the geofence. So that's kind of like an area that we tell the drone, you have to stay in this area. It hit the geofence, and we forgot to tell it before it took off what to do if it hit the geofence. So it did strange things. And this particular drone, went into a new mode, and it flew in a random direction, which we think was actually the direction of the wind. And it kept ascending higher and higher. And we know why it did it now. And it went up to 734 feet, which is a lot higher than 400 feet. So technically, we had broken, the regulations of the FAA. So we reported it. And, if you report things and no incident has occurred, then you are forgiven. And but those are the kind of things, drones, it's a whole new area. And when you're writing programs for them, we try our best to make sure that nothing goes wrong. But it's like experimenting, and sometimes things do go wrong, and then you learn from your mistakes, and you make sure you fix those program errors so that does never happen again.
Wow, that must have been nerve-wracking. I can imagine when the drone's just flying away and you're just helpless. What do we do?
It was nerve-wracking and also a little exciting afterwards to find out that because we have a project where we have to fly actually to 1,000 feet, and we'd never done it before. So we accidentally tested for it. So, but we would have to get the specific waiver for the days that we want to do that, and we didn't have it this day.
Sure, sure. And what is that, like a 90-day? You give them a heads up or something? Or how's
Well,
that
we fly, we fly, the test flights we fly are actually at an air base. And so there's actually real planes, military planes coming in and out. So we have to, it's very safety critical. We have to make sure everything is perfect for those tests.
I
So.
bet. So we'll go with two more questions. So one of the final questions. So they want to know, what kind of jobs can someone explore with their drone, the 107 license? If like they're pursuing that as a career, what kind of careers are out there that are drone related?
So I think that there's so many different kinds of drone jobs now and new ones emerging. So the first one is that you are a drone operator. So that means that you know how to fly the drone. You have your 107 license or whatever license your country wants you to have. And then companies are going to hire you to operate the drones to do things like inspect bridges or, run work for agriculture, for farmers to go and inspect their crops. So you would then be or kind of take videos for commercial real estate and things like that. So that would be a drone operator. And you'd obviously have to know all of the rules. You'd have to be very proficient at flying and those kind of things. The second kind of job is a programmer. And this means that if you've ever, actually written code, for software, you now do it for the drones. And this is a rapidly emerging field of development because there's lots of spin-offs, lots of new companies like Drone Response and other companies. So, as we are getting increasing funding for the company, we're hiring programmers because there's so much code that has to be written to make these drones smart. And then I think the third kind of job are the engineers. Somebody asked the question about hardware, and that's the question I did not answer very well. I'm sorry, Jose. But that's because we have specialized people that are really good at that side of it. So they know how to build drones from scratch. They know about the electrical engineering part. They know how to make sure that the drone is designed properly so it's going to stay in the air. And they know how to configure it for use. So I think those are the three main kinds of drone jobs that you could get. But this is a new market, and there's all sorts of new jobs coming up all the time.
That's so exciting. And I'm so excited for all you kids out there because this wasn't around when we were younger. So Professor Jane, before we let you go, is there any advice that you could give to this next generation as they go out into the world, whether they want to go into drones or something completely different? What kind of advice can you impart on them?
Okay, well, I think first of all, you are all on a great path because you came to this and other talks like it. So it shows that you're curious, that you want to learn. And I think that's the first great step. I'll tell you one secret. When I was young, about your age, I would never in a million years have ever imagined that I was going to be a professor or that I was going to be working with drones. So I think, work hard, because if you work hard, it's going to give you more opportunities to do things. And just, follow your dreams. So think about what you want to do and, work towards that. So for many of you, you're in school and you're going to think of going on to college. In some ways, it's not so important exactly what degree you do, but whatever you do, just put everything you have into it, because that gives you the opportunities to do whatever you want to do after you finish that and moving on. So just really dream big. And I love the fact that I'm seeing some girls here in this crowd, because sometimes there's, you know, lots of boys and that's great. But, you know, this is a field kind of technology that there's room for everybody. So yeah, dream big, work hard, and doors will open for you.
That is wonderful. So thank you again, Dr. Jane, Professor Jane, for spending your very valuable time with us. Before I end the meeting for all, I'm going to allow everyone to unmute. And usually, traditionally, what I'll do is I'll have these kids say thank you, a collective thank you. So can we all say thank you to Professor Jane for spending time with us to talk to you about our career? Thank you so much, Professor.
You're welcome.
Thank you.
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 Thank you.